Hello everyone, I am Maurice Moneni. In today's session we are going to discuss the chi-square to determine or to test the hypothesis when given the observed values in a given set of data. So for our case here, for us to be able to get the chi-square, we need to identify our hypothesis. So in this case, this one is our x squared. And for us to be able to identify this chi-square, we first of all need to get our null hypothesis and our alternative and hypothesis. So in this case, our null hypothesis or hypothesis we can say that hypothesis we can see that there is no relationship between the marital status and education qualification. And in our alternative hypothesis here, that is the alternative hypothesis, we can say that there is a significant relationship between the marital status and education qualification. So for us to be able to compute or to work out the chi-square, we need first of all to have the significant level, and in this case we are going to use the significant level of alpha is equals to 0.05. So that is what we are going to compare with after we get our chi-square, after we compute the expected values, so that we can be able to identify if we reject the null hypothesis or we agree with null hypothesis. So the first thing that we need to work out is for us to get the table of expected values. So let us calculate the table of expected values. So for us to be able to calculate the table of expected values, here we need to get now to compute the expected values. So let us compute the values for the middle school, that is the expected values, the expected values. And how do we calculate the expected values? For us to be able to calculate the expected values, like maybe for the never married, where we have 18, we need here to have, we multiply the total of that column, which is 90 multiplied by the total of, that is the total of that row multiplied by the total of that column, which is 39, divided by the total of the observation, which was 300, and here we get the total as 11.7. The same case we get the high school. We know that that row has the total of 90, then multiplied by the column for the high school, we had the total being 90, then we divide by 300 and we get the total being 27. So here we get 27. Then we also calculate the bachelors, and for us to calculate the bachelors, we need to multiply the total of that row, which is 90 multiplied by the total of that column, which is 84. Then we divide by the totals of our data, which was 300, and in this case we get here as 25.2. So that is how we can get the expected values. So to save time, I'm going to feed out on what I have calculated for the others. So here my expected time here becomes 16.2, and here my expected value becomes 9.9. So on the married column here I have 19.5, and here I have 45, then followed by 42, then followed by 27, then followed by 16.5. 5, and then followed by 3.9 here, and then we have 9, then followed by 8.4, then followed by 5.4, then followed by 3.3, then followed by, here we have 3.9, then here followed by 9, and here followed by 8.4, and here we have 5.4, and here we have 3.3. So that is how we calculate the expected values using the totals of the row multiplied by the totals of the columns multiplied by the total of the data that was observed. So for the next, for us to be able to get the expected value, we need to calculate the x squared or the chi-squared. And for us to be able to calculate the expected value, we know that the chi-squared or the x squared will be given by the observed value, then we subtract the expected value, then all these we divide by the expected value, and then all these we square out. So in this case, this one is going to give us our chi-square. And for us, because not everything that will fit here, we need to get first of all the observed value. And in case here our observed value, if you remember, if you take the first column, that is never married, we had 18, and then we also had 36, and then we also had 21, then we also add from 21 we also had 9, and also we had a 6. That is, we are done with that first row. And then the expected value that we have arrived at, remember we had 11.7, and then the second one was 27, and then the third one was 25.2, and then the other one was 16.2, and then the other one was 9.9. And then now from there we can get the difference between the two columns, that is the observed value minus the expected value. And in this case here, when we get 18 minus 11.7, here we get 6.3, and then we get 36 minus 27, we get a 9 here, and then here we have negative 4.2, and then we have negative 7.2, and then we have negative 3.9. So from that perspective, we can be able to get our expected observed value minus expected value, then we square. So we are going to square 6.3. Here we get 39.69. At 9.69, we get 9 squared, we get 81 here, and then we square negative 4.2, we get this one to be 17.64, and then we also square negative 7.2, we get this one is 51.84, and then we square negative 3.9, we get this one is 15.21. So now from there we can be able to compute out our chi-squared, which is the observed value minus expected value divided by the expected value. Then we square that as the first one, and then from that perspective here, if we take that is 18 minus that we get 39.69. Then we divide 8 by the expected value of 11.7. In this perspective here we are going to get 3.39, and then here we can get this one to be 3, and then here we have 0.7, and then here we have 3.2, and then here we have maybe the other one, we have 1.53. So that is the one rule. Remember, we can be able to solve the other columns. Maybe for example, like the second one, I had here 12, so the expected value was 19.5, and here we have now the difference between the two, which was negative 7.5 also here, and now the difference gives me 56. If I square them, I get 56.25, and then here if I divide by that, I get to negative 2.88, and then I have also 36, and then this one I get expected value was 45 here, and then here I add negative 9. If I square this, I get it 1, and if I can compute out this, I get this one being negative that is positive 1.8. all the way this. To save time, I can compute out that I get the last value, which is 3, so I have 3.3, and then I have the difference is 0.3, and then if I square this, I get 0.09, and then here I have 0.02. So if the first thing that I need to get, for us I can be able to get the chi-squared, I need to get the summation of my observed value minus expected value, this squared, then divided by my expected value, and here this gives me my x squared, which is equivalent to 23.57. So now I can conclude that my chi-square is equals to that is the calculated one. We have seen it being equivalent to 23.57. So now we can be able to compare our values in the chi-square, and then we can be able to get the degree of freedom, and for us to get the degree of freedom here, we need to say that our chi-squared, or our degree of freedom, the degree of freedom is given by the columns, then minus 1, then all these we multiply by the rows minus 1. So in this case we have 5 columns, so we are going to have 5, then minus 1, and then we have 4 rows, so we have 4, then minus 1, then we multiply this, so that we get 4 times 3, which is equals to 12. So now considering our significant level that we are given of 0.005, and then we have the 12. So if you read it from the table, we get that if we use that is the chi-square tabulated, will be equivalent to 21.0 21.03. And if you find that maybe our x calculated is greater than our x tabulated, we call this one maybe the critical values. We can conclude that we reject the null hypothesis. And conclude that alternative hypothesis, that is, there is significant relationship between the marital status and the qualification, that is the education qualification. So that is what we can conclude from this our reading. And that brings us to the end of this session. I was your trainer, Maurice Monene. If you found this video of great impact to you, consider subscribing, like, and share it to many so that they can have the same knowledge. Thank you very much.